So let's take the same data, right? So I'm going to give you these 10 numbers, and let's say we want to find one number that could completely distort our analysis, right? So this is the customer spending data that we have taken, right? Okay. Now take a look at this and think about it for a second, that which value looks suspicious? Obviously 50,000, right? But here's the problem. How do you prove mathematically that 50,000 is actually an outlier? What if I could have taken here a data as 10,000? Would it be an outlier? How would you prove mathematically? And what if the outlier is not this obvious, right? Today, using Excel technique, we are going to see that how we can detect outlier using few calculations in the Excel, right? At the end of this lecture, I'll make sure that that Excel you learn how to detect the outliers with the help of Excel, right? Okay. Your eyes can identify obvious outliers, but the data analysts don't just say that number looks weird. We need a rule, mathematical rule, right? And one of the most useful rules for detecting outliers is called as IQR method, interquartile range. But don't worry, you don't need complicated mathematics. We are going to build this entirely inside Excel. First, we need to divide our data into 4 parts, right? Very important numbers, right? We have 4 quarters. Quartile 1, quartile 2, quartile 1, then we'll be talking about quartile 3, okay? Right? That's how we need to divide our data. And we also need median also, right? Okay, that is what we'll be talking about, okay? And then we'll use the formula and the function, okay? So this is very, very important, right? So we divide our data, right? Okay, and the first thing is to do what? Calculate quartile 1. But how do I find the quartile 1, right? We definitely use a formula in order to find this quartile 1 range, okay? But for that we don't have to rely on these equations and so on. We have the functions available in the data, right, that we can use very clearly, okay? And then we'll be producing the equations to further find or detect outlier, okay? So interquartile is nothing, interquartile range nothing, just you're defined as quarter 3 minus quarter 1. This is the data, okay? So quarter 3 minus quarter 1, this is what we call it as interquartile range, okay? For that we need to find the quarter 1 and quarter 3, right? And then we set which value is belongs to outlier or not an outlier, right? So let's move forward. So which function we have to use for finding the quartile, right? We have the functions quartile that we are going to use, okay? Quartile inc, this is the function that we are going to use. It will return the quartile of a data set based upon the percentile values from 0 to 1 exclusive, right? Okay, so in that we have to pass the entire array, because how we can we need to find the quartile 1 and quartile 3 value. Yes, we can also do that. For example, the 25 percentile value I mentioned, right? Okay, and the 75 percentile value is quarter 3, right? For example, if I'll give you a data 1 2 3 4 5 6 7 8 9 and 10, right? So which value will be quarter 1? 25th percentile value, right? That is 2 point in this particular data. So my quarter 1 will be equals to 2.5, and my quarter 3 will be equals to will be 7.5, right? 25 percentile and 75th percentile. But this is not a sequence data, right? This is some different values that we have. So it becomes quite difficult for me to find this 25th percentile value, right? That is the reason what we are going to do. We'll use the function, right, which is available to us. So I'm going to select the entire array A2 to A11, and I'm going to give that which quartile I want to select. So I want to select the first quartile, that is a 25 percentile of my data, right? Okay, so I'll mention here 1. So this is quarter 1 and it finds the value. Similarly, I'll apply the same function again, quartile inc, using this array, and I'll want to find the third quartile data, that is 375 percentile. Okay, so this is my quarter 1 and this is my quarter 3, which I have identified it, right? Okay, so you no need to memorize everything, right? Okay, we have functions, all these available here, so there's no need to memorize the formula. Perfect. So we got this value right. If you are interested in finding the middle value, that is 50 percentile, you can also get that, right? Okay. So now the key question, how we are going to measure the spread of our data? Simple, right? Of the interquartile range, we subtracted. Okay. So my interquartile range for this given data will be equals to quarter 3 minus quarter 1, which is present in E4 and E3 respectively. So I got my interquartile range 700. This 12.5. This is my interquartile range. Now think of interquartile range as the size of the central portion of the data which lies between 25 percentile to 75 percentile. This is the data. And now comes the part that actually allow us to detect outliers. So we'll create two boundaries, right? Okay. So we create two boundaries. One we create lower bound and one we create as upper bound, right? Okay. One we create is upper bound. What is lower bound? For lower bound, if any value equals to 1.5 minus quarter 1.5, I think I remember the formula, yes, quarter 1, sorry, yeah, equals to quarter 1 minus 1.5 into IQR. So if any value less than to this, okay, if any value less than to this will be an outlier, okay, and if any value greater than to quarter 3 plus 1.5 into IQR will also be an outlier, very simply, right? So we need to now define our lower bound and upper bound. Is it all right? The lower bound will be, I have the formula equals to quarter 1. What is the value of quarter 1? This minus 1.5 multiplied by, we have our interquartile range, which is this. So this is our lower bound. And what is our upper bound? That will be equals to quarter 3 plus 1.5 into IQR, which is this. So we got our lower bound, upper bound. Anything below the lower boundary, anything above the upper boundary is considered as a potential outlier, right? So we don't need to just see from eyes and then state that. We have mathematical equation with which we can find. Okay, so 4 things very important: quarter 1, quarter 3, interquartile range. 5 things, sorry, lower bound or upper bound. Instead of manually checking that, you can obviously make that Excel also work, right? Okay, now I need not to check manually. I have learned if condition or if function also, right, in one of the class, so I can just use that. If, okay, so I need to check that if this value is either less than upper bound or greater than lower bound, is less than upper bound, less than lower bound, or greater than upper bound will be an outlier. That is what I need to check, right? So if my value of A2, if it is less than this lower bound value, right? If it is less than this lower bound value, okay, comma, right? That is what I need to use. Or if my value A2 is greater than to this value, out of this one scenario, so for that I will be using or. Okay, so I'll be putting this entire statement in the bracket and I'll be using or function here, right? Okay, or to check that whether one of the condition is true. If one of the condition is true, then we stated that it is an outlier, else we'll say it is a normal. That is what we can also refer to as, right? If as true condition, right? If this is true, then we'll print this, else we print this. Okay, simple thing. That is what. Now you see here this value is in the range of 68 to 291.8, right? So it is normal value. Now if I'm going to drag the formula, all these cells are having a reference, right, which is relative reference. That means they will also move. And if they move, my E12 and E13 value will also move, which I do not want because these values are fixed, right? And I told you, if you want any of the reference to be fixed, you use absolute reference, right? So I'll put here $E, $12, and I'll put $E, $13. So in case I drag my formula, these two values will always remain constant, right? These 68.75 and 291.18.75. Rest A3, A4, A5 will have to change as per the condition we need to match, right? So now I'm going to drag it, and you see, using the Excel, we have just seen here that what the value which was looking suspicious, Excel has mathematically identified it. Okay, but here something also very important: interquartile does not tell you to delete the outlier. It is just detecting outlier, right? This value deserves investigation. Maybe it is a typing mistake, genuine bulk order, maybe it is a VIP customer, right? So IQR answers is this value unusually far from the rest? But you have to answer why it is unusual, right? Okay, so we took the data, we find quartile 1, quartile 3, interquartile range, lower bound, upper bound, and then we detected outliers. We have not taken a decision what to do with, but we have just seen how to detect. So that's the complete IQR method in Excel. But we have just answered only one question, how to detect it, right? So the next question is very important, that what should we do with that outliers? So for that, I request all of you to take a pause on this video and look for this answer and comment, right? That should be deleted, corrected, cap it, transform it, whatever, right? And that's where data processing gets really interesting. Okay, so that's it from my side for today's session. So keep learning, keep growing, and follow Mindic site for more videos.